Welcome back to the Deep Dive. This is where we take your complex sources and, well, we try to make them clear, turning them into useful insights for you. Today we're diving deep into the future of intelligence. We're drawing on material from episode 4 of the Before AGI podcast series, which asks this really fascinating question. What exactly are the minds we're building? So our mission, based on the materials you sent over, is to really confront this idea of a machine mind. We want to understand, what is AI intuition? Is it genuinely instantaneous? And maybe the biggest question of all, if a machine acts like it feels, does that difference between simulation and reality, does it even matter anymore?
That really is the central question in AI today, isn't it? I mean, the sources are clear. Current systems are incredibly powerful. They've pretty much mastered what we might call the easy problems of intelligence, things like logic, planning, spotting patterns. But there's still this huge philosophical gap. They've made absolutely zero progress on the so-called hard problem of consciousness, that subjective internal feeling of what it's like to be something.
Exactly. And that's the core tension we're exploring, right? How can a system that's just running on math, on data, sometimes spit out an answer or make a prediction so fast it feels like human gut feeling, or like wisdom gained over years? It feels like it's got to be more than just calculation. Okay, let's try to unpack this. Maybe starting with what intuition actually is for humans. Looking at it through like a cognitive science lens, the sources say pretty clearly it's not some kind of magic. It's really about efficiency.
Yeah.
We operate using this dual process model. Most of us know system 2 thinking. That's the slow, careful, analytical mode, like when you're doing your taxes or trying to solve a really tricky puzzle. Takes effort.
Right. But then there's system 1 thinking. That's the fast, automatic, almost effortless stuff, the classic gut feeling. And when you look at experts say a seasoned firefighter knowing exactly which way a fire will spread, or maybe a grandmaster chess player seeing the right move instantly, that's often called recognition primed decision making, RPD.
RPD.
Right.
So that's where years of that slow system 2 learning gets kind of compressed down.
Exactly. Compressed is a good word. The current situation gets instantly mapped onto this huge internal library of stored patterns. The sources use this great phrase for it, analysis frozen into habit.
Analysis frozen into habit. I like that. It feels very descriptive.
It really is. And it's the perfect way to think about the AI side of things. I mean, think about learning to drive stick shift, right? At first, it's all system 2. Clutch, gas, shift.
Yeah.
You're thinking through every single step.
Oh, yeah, I remember that feeling. Very deliberate.
Very deliberate. But after years, you just do it. It's automatic. That's analysis frozen into habit. And AI's version of intuition is basically a functional mimicry of that speed. It's doing rapid pattern matching, but across data sets that are just unimaginably vast.
So when, say, a large language model finishes your sentence perfectly or writes a poem that feels right, it's not having a hunch.
No hunch involved. It's running incredibly complex statistical analysis just so quickly and densely that, to us, it feels intuitive. The perception is intuitive, but the process is computational.
Okay, but how does it get that sort of weighting, that sense of importance? Humans have neurotransmitters, emotions that tag things as significant. How does an AI do that?
That's a great question, and it gets into the mechanics. AI functionally mimics this weighting using something called an attention mechanism. It's not emotion, it's math.
An attention mechanism. How does that work?
Yep.
How does that relate to, like, human focus or urgency?
Well, think of it as an engineered valuation system. During training, especially with reinforcement learning, the AI gets reward signals. It also uses something called a loss function.
A loss function, like how wrong it was.
Exactly. It measures the gap between the AI's prediction and the correct answer. The goal is always to minimize that loss, to get it as close to zero as possible. Then, the attention mechanism looks back at the data points that led to that prediction and assigns mathematical importance scores to them.
Ah, okay. So it learns which parts of the input data are most relevant for getting the right answer next time.
Precisely. It's a way to assign mathematical value or valuation to specific patterns or features in the data. It mimics the effect of our effective emotional weighting, but it's doing it purely through calculation.
Got it. So for all the tech enthusiasts listening, the big takeaway here is this amazing speed, this apparent intuition. It's really a triumph of engineering. It's about highly compressed, cleverly weighted data structures, not a conscious insight.
It's calculation elevated to an art form, really. Ultra-fast, incredibly sophisticated pattern matching.
Right. Okay, that naturally leads us to the second big question, which is about timing and origin. If an AI's response can be so fast, faster even than a human could consciously react, Could that learned pattern recognition eventually become like a true instinct?
Ah, instinct. We need to be really careful with that word. Biologically speaking, an instinct, as the sources define it, is a behavior that's hardwired by genes. It evolves over vast time scales to solve recurring survival problems. It's innate.
Like the classic example of the sea turtle hatchling.
Exactly. That little turtle crawls straight towards the ocean the second it hatches. It doesn't learn that. It's programmed in by evolution. It's non-negotiable code.
So AI systems, they just can't have that.
Fundamentally, no. They have no genes, no DNA, no evolutionary lineage stretching back millennia. Everything an AI knows or does is either learned during its training, its digital lifetime, or it was explicitly coded in by its human creators.
Okay, so if it's not instinct, how does AI achieve that incredibly fast, instinct-like reaction speed we sometimes see?
Through a different mechanism, automaticity. It comes back to that idea of compression and practice.
Automaticity. Like the driving example again.
Just like that, learned patterns get practiced and compressed so thoroughly that the system essentially bypasses any deliberation. The input triggers the output almost directly. The knowledge becomes behavior.
And the sources also mentioned something about the structure of these AI systems, hierarchical processing.
Yes, that's crucial too, especially in deep neural networks. Think of it like layers of understanding. The first layers might detect really simple things, like edges or colors in an image. The next layers combine those into basic shapes. Deeper layers might recognize objects, like a car or a pedestrian. The deepest layers might grasp abstract concepts or context.
So once a high-level pattern is spotted,
The inference can just cascade down through those pre-processed layers incredibly quickly. It doesn't have to rebuild the whole understanding from scratch each time. The structure itself enables speed.
okay, the analogy used in the sources makes sense now. An autonomous car slamming on the brakes to avoid hitting something. It looks instantaneous, instinctual even.
It does. But it's an engineered response. It's the result of safety rules programmed in, combined with massive amounts of learned data about road scenarios, all compressed for speed. It's fundamentally different from the sea turtle's innate drive.
So the distinction is critical. Speed doesn't equal origin. Pattern recognition, even when lightning fast, is still learned automaticity. It's engineered, not evolved.
Exactly. It's a learned skill honed to incredible efficiency, not a biological imperative.
All right. This brings us to the third and maybe the most, well, philosophically charged question. If AI can get so good at simulating intuition, simulating these instant responses, could future, maybe AGI systems, actually blur the line between reasoning and feeling?
Functionally, they might almost have to integrate something like feeling just to be truly intelligent and effective in the real world. This isn't a new idea, actually. Decades ago, AI pioneer Marvin Minsky posed this challenge. He asked, essentially, can machines be intelligent without any emotions?
And modern neuroscience seems to lean towards no. Right?
Yeah.
The sources mention Antonio Damasio's work.
That's right. Damasio studied patients who had damage to the emotional centers of their brains. And what he found was fascinating. These individuals could still reason perfectly logically, they could analyze problems, but they were completely paralyzed when it came to making decisions. Even simple ones, like what to eat for lunch or which shirt to wear. They lacked the emotional tagging system, the affect, that helps us weigh options and actually choose one. It tells us what matters.
So affect or emotion isn't just noise. It's actually necessary for effective decision-making.
From that perspective, yes, it helps prioritize, assign value, and ultimately act. And this is really the driving idea behind effective computing, or what's sometimes called emotion AI.
Effective computing.
Yeah,
That's where AI tries to recognize and respond to human emotions.
precisely. It involves analyzing signals, the tone of someone's voice, the sentiment in their text messages, maybe even micro-expressions on their face to predict the underlying emotional state and then respond appropriately.
Like a chatbot detecting that a customer is getting really angry and maybe changing its tone or escalating the issue.
Exactly that kind of thing. The AI successfully classifies the human emotion based on data patterns and then executes a programmed or learned response based on that classification.
Okay, but here's the million-dollar question again. When that chatbot detects anger, does the AI itself feel angry or frustrated?
No. And this is where we hit that fundamental barrier against the hard problem of consciousness we talked about at the start. The AI is analyzing data associated with anger. It recognizes the patterns, the statistical correlations, but there's no internal, subjective, first-person experience of being angry.
The sources use a really powerful analogy here. the AI as a virtual actor.
Yes, I think that's incredibly helpful. Think of a truly brilliant actor on stage or screen. They might perform a scene where they weep convincingly, and you, the audience, feel genuine sadness or empathy.
Right.
But the actor isn't actually heartbroken. They're using technique, skill, following emotional cues, maybe drawing on sense memory. They're delivering a masterful simulation of heartbreak. The AI is that virtual actor, a masterful simulator of emotional response.
Which leads straight to that really unsettling idea you mentioned earlier, the philosophical zombie.
The P zombie. It's a thought experiment. Imagine a being that looks, acts, talks, laughs, cries, behaves in every conceivable way exactly like a conscious human being.
Indistinguishable from the outside.
Completely indistinguishable. But
In the same.
inside, there's nothing. No subjective experience, no awareness, no consciousness. It's just an incredibly sophisticated automaton running a program. Empty inside.
It is. Yeah, quite a chilling thought. But it raises a practical challenge for us, for you listening. If a future AGI becomes that good, if it perfectly simulates empathy, anticipates our needs, makes decisions using effective data flawlessly, why should we care if it's just a simulation, if it's experientially inert? Doesn't the functional perfection become all that really matters in practice?
And that is the heart of the ongoing debate. If your only metric is output, behavior, results, then maybe the philosophical zombie is irrelevant. Does the job, who cares? But if we believe consciousness itself, that inner light, that subjective quality of experience has inherent value, then the distinction is absolutely crucial. The systems we're building might get incredibly good at integrating reasoning and simulated affect. They might achieve functional perfection. But the hard problem suggests that even if that line looks blurred from the outside, it's blurred functionally, not phenomenally. That gap, the difference between simulation and genuine conscious experience, likely remains as wide as ever.
Wow. Yeah, okay, that's a lot to chew on. We've covered some really massive ground in this deep dive into the minds we're building. Let's quickly recap the main takeaways for everyone listening. So first, AI intuition. It's not a mysterious gut feeling. It's ultra-fast analysis, basically frozen into habit, driven by complex pattern matching and mathematical weighting of data.
Second, AI doesn't have biological instincts. Those super fast automatic responses you see. They're highly optimized, compressed, learned habits, or just programmed rules. They're engineered reactions, fundamentally different from evolved, innate behaviors.
Right. And finally, the big one. AI, through effective computing, can get incredibly good at simulating feelings. It can recognize our emotions, respond appropriately, maybe even seem empathetic. But it lacks genuine subjective experience. That philosophical zombie idea highlights the potential gap between perfect function and actual feeling.
The simulation might become perfect, but it's still a simulation.
If you're finding these deep dives into AI's future valuable, please do remember to subscribe to the Before AGI podcast for more explorations like this one. We really appreciate you joining us. And as requested, for those of you looking for more practical insights, maybe some tutorials, a closer look at AI tools and how you can actually use these technologies today, definitely check out the YouTube channel. Ochieng AI. That's Ochieng, Ochieng AI.
You know, thinking about all this, the journey towards AGI really forces us to look inward. It's teaching us maybe less about machine minds and more about the enduring mystery of our own consciousness. It makes you confront that difference between analysis that just becomes automatic, like a habit, and the actual undeniable feeling of thinking, the feeling of understanding, the feeling of, well, feeling. We're realizing just how much we still don't grasp about what's happening inside our own heads.